going to look at an example applying Malus's law for the amount of light that's transmitted through a polarizer. So a little bit about the notation here. So we're starting off with unpolarized light, and our representation for that is basically the plane of polarization is equal parts up, down, catty corner up, catty corner down. So that would be unpolarized light. This is a polarizer that is aligned horizontally. This bottom one is a polarizer that's aligned vertically. And then the one in between the two is aligned at 45 degrees to both the horizontal direction and the vertical direction. Okay. If this polarizer were absent, then no light is going to get through this combination of two polarizers because no part of horizontal points along vertical. So any light that passes through this first polarizer has to be absorbed in the second. And so we'd have complete darkness down here. Now I've introduced this intermediate polarizer that's at 45 degrees. And we want to work out if the initial intensity of the unpolarized light is 10 watts per square meter. What is the intensity here after passing through the first polarizer? Intensity after passing through the second polarizer? The intensity after passing through the third polarizer. Alright, so for this first polarizer, I have unpolarized light initially. After it has passed through the polarizer, it is horizontally polarized, and I will have lost half of the light. Half of the light will have a projection along the horizontal direction. The other half of the light has a projection along the vertical direction. This is unpolarized light, so that's an equal mix, half and half. So I will get an intensity 1 of 5 watts per square meter. All right, now horizontal light, after it passes through this polarizer, is going to be polarized at 45 degrees, same as the orientation of the polarizer. And we want to find I2. This is where we'll use Malus's law. I2 is going to be the incident intensity I1 times cosine squared of the angle between the plane of polarization and the polarizer. So this is going to be 45 degrees. Okay. Cosine of 45 degrees is 1 over root 2. I square 1 over root 2, I'm going to get a half. So intensity 2 is going to be intensity 1, which is 5 watts per square meter. Cosine of 45 is 1 over root 2, which I square. So this is going to give us 5 watts per square meter over 2, which is 2.5 watts per square meter. All right, now that light that is polarized at 45 degrees to the horizontal is going to pass through a vertical polarizer. And the light that passes through this is going to be vertically polarized. And we want to find the intensity again. So that is going to be the intensity I3, which is going to be the incident intensity on a polarizer, which was I2, and the angle between the plane of polarization and the angle for the polarizer is again 45 degrees, because this is at 45 degrees to the horizontal, which is also 45 degrees away from the vertical. So I'm going to have again cosine squared 45 degrees, which is going to be I2, 2. So half of I2. So that gives us I3. It's going to be 1 1/4 watts per square meter. in general, for Malus's law, the transmitted intensity is going to be the initial intensity times cosine squared theta, where theta is the angle between the polarization plane for the incident light and the polarizer. If the plane of polarization and the plane of the polarizer are the same, then theta is equal to 0 and cosine of 0 is 1. So the transmitted intensity will be the same as the incident intensity. If I have rotated the polarizer by 90 degrees compared to the incident light, then cosine of 90 degrees is 0, 0 squared is 0, the transmitted light intensity will be 0. And you can get anything between all of the light being transmitted to none of the light being transmitted. So just remember, for Malus's law, this angle is the angle between the plane of polarization of the incident light and the polarizer.